Hello everyone, welcome back to another episode of our IPRAN training series. Remember, in this series we discuss how to implement the IPRAN technology on service provider networks. So thank you for watching again, and if you are watching this video and you are yet to subscribe to our channel, kindly hit that subscribe button to support our channel and also to stay tuned for more upcoming videos. So in our last episode we discussed how to implement the HOVPN solution, hierarchy of VPN solution on Huawei routing devices. Remember, with the HOVPN solution, we are only advertising the default route. So from the SPE to the UPEs, we only advertise the default route. That is the 0.0.0 is advertised from the SPEs to the UPEs. So whenever the UPEs want to access any network that is outside or a remote VPN, they only have to use the default route that is advertised from the SPEs towards the UPEs. And then the SPE will also advertise routes to the NPE, the specific or detailed routes, and the NPE will also advertise the specific detailed route to the SPEs. So the key feature of the HOVPN solution is that we are using a default route from the UPEs. The SPE only advertises the default route. So if you haven't watched this implementation of HOVPN, remember to check it out on our last episode and have a look at it. So in this episode, we'll be focusing on how to implement the HVPN architecture, the hierarchical VPN solution for IPRAN network. So we are still having the same nodes. We have the NPEs, we are the SPE, the UPEs, and the BTS, and we have the VPC that is representing the controllers. So we are using the same setup we used in our last episode. We have the aggregation and the access processes, and we'll be configuring BGP peering sessions, the MP BGP peering session between the SPEs and the NPEs, the SPEs and the UPEs. And then we also need to configure the VPN instances and advertise the routes to the BGP. So with HVPN solution, the only difference with HOVPN is that we are now advertising the specific route. So from the SPEs, we are advertising all the specific routes from the SPEs to the UPEs. So UPEs will have to learn all the specific routes that are being advertised. Many times we control this using the route targets. Remember, service provider network will always span multiple regions. So we end up controlling the route advertisement or the route import using the route target. So every region will have different route targets so that we don't send all the information from other regions to the UPEs. So with the HOVPN solution, I've mentioned that we are advertising all the specific routes from the SPEs to the UPEs, from the SPEs to the NPEs. So we have the SPE acting as the route reflector, and then we have the UPEs and the NPEs acting as the route reflector client. So that is the key feature of the HVPN solution. We advertise all the specific routes to the UPEs and the NPEs, and the SPEs will always act as the route reflector. So we have this setup. We have IS-IS 100 used as aggregation IS-IS, and then we have IS-IS 10 used as the access IS-IS. We have BTS 01 and BTS 02, which will be simulating user equipments or the CEs, and then we have VPC. I've mentioned that this one will be simulating the controllers. So the configuration steps are almost the same with the HOVPN solution. So let's go through the configuration steps. So step one will be configuring the system. As usual, we always start by configuring the system names and the interface IPs. So let me highlight. So we are starting by configuring the system and assigning IP addresses on UPEs, SPEs, and NPEs. In step 2, we are configuring IGP. Remember, we need to configure IGP for reachability between different nodes, all the way from UPEs to SPEs and NPEs. So we are using IS-IS, and I mentioned that we also split it into access and aggregation IS-IS processes. Next step will be to configure MPLS, MPLS LDP on UPEs, SPEs, and NPEs. So we configure MPLS, we enable MPLS LDP globally and also on the interfaces that are that are part of our MPLS backbone network. Then the fourth step will be to configure VPN instances. So we configure 3 VPN instances, one for 2G service, another one for 3G service, and another one for 4G service. So you can have as many VPN instances as you want depending on the requirement of your network. You can have separate for signaling, you can have separate VPNs for data. On the fifth step, we establish MPI-BGP peer relationship between UPEs and SPEs and between SPEs and NPEs. So we are configuring BGP peering session, MP-BGP, VPN-v4 peering session between UPEs and SPEs, and then SPEs and NPEs. And then the sixth step will be to configure SPEs as the route reflectors. Remember, I mentioned which H-VPN solution, we are advertising all specific routes to the UPEs and NPEs. Remember, BGP has a concept of split horizon. So, for example, if UPE advertises a route to the SPE, this is an IBGP peering relationship, so the SPE will not advertise it to the NPE by default. The split horizon is in place. So, even when NPE advertises a route to the SPE, the SPE will not advertise it to the UPE. Still split horizon in place. So we need to configure SPE as our route reflector so that it will be able to advertise the route that are being learned from the NPEs and the UPEs to each other. So that's why we need to configure our SPEs as the route reflectors for this network setup. And it's always very simple. We'll see it when we start the configuration. And the final step is now to configure services on UPEs and test reachability. So we'll configure services on our UPEs, configure the BTS, and then test that we are able to learn the MAC addresses from the BTS side. We are able to learn the routes on the UPEs and the SPEs. So that will be the final step of our configurations. So we already went through the configuration in our previous episode of H-VPN solution. So we'll just take a quick look at the configuration and then verify that we have everything in place. So all the configuration are already run apart from the part of making the SPE the route reflector and also configuring service on the BTS. So this is the first step. We are configuring system name and IP addresses on the UPEs, SPEs, and NPEs. So these are the configurations. Very simple. The system name and assigning the IP addresses on the physical interfaces and the loopback interface. So same configuration on the NP01, SPEs, and UPEs. So these are simple stage. And these are the configuration, just system and interface configuration, both logical and physical interfaces. So we can verify that we have the IP address configured in place. If I run display IP interface brief, you can see that we have IP addresses configured on the physical interfaces and also on the logical interface, loopback 0 interface. On UPEs, we have the same display IP interface brief. We have IP addresses configured. So you can use the command display IP interface brief to confirm that your IP address configurations are okay. The next stage of our setup is to configure IGP. So we are using IS-IS. So we need to configure IS-IS on UPE, SPE, and NPE. And we are using different access and aggregation process. So starting with the NPE, we only configure the aggregation. We are configuring IS-IS 100. Both routers will be level 2, core style is set to wide, the network entity is derived from loopback 0 IP address, and then we configure IS name for easy identification of the peering relationship between different nodes. And then we activate IS-IS on the interfaces, physical interface and also the logical loopback 0 interface. Because remember, at the end of the day, we are using loopback 0 for other uses, for MPLS, LDP, and also for BGP configurations. So similar configurations are applied on NP02. And then on SPEs, we are creating two processes. We have the access process, IS-IS 10, and IS-IS 100 for aggregation. Then we activate on the relevant interfaces. So facing the access, we activate IS-IS 10. Facing the aggregation, we activate IS-IS 100. On the loopback, it will also be in IS-IS 100. So similar configuration are done on SP02. And then on the UPEs, we create the access process, IS-IS 10. IS-IS level is set to level 2 also. Cost style is still set to wide. The network entities generated from the loopback interface, and then we configure the system. We do the same for UPE2. So these are the IS-IS configuration. We can verify that we have our IS-IS peering relationship up. If I run display IS-IS peer, you can see that we have one access IS-IS adjacently, and then we have two for the SPE towards the SP02 and also towards NP01. So we can do the same on this router, display IS-IS, all IS-IS 10 peer. Then you can also do IS-IS 100 peer if you want to check just for specific process. But if you want to see both of them, display IS-IS peer, you get to see all the relationship that are up on this router. So we have one in IS-IS 10 and two in IS-IS 100 as expected. So on UP10, on UP display IS-IS peer, we have two peering sessions, one to SPE and another one to the connected UPE. Display IS-IS 1, IS-IS peer, you have the same details. So this one verify that our IS-IS configuration are okay, and we have adjacencies established between different routers as expected. So once we've done the IS-IS configuration, the next step, that is step 3, we need to import routes between access and aggregation IGP processes. So for us to be able to communicate or to have the routes advertised from one process to another, we need to perform route import. We've explained that before. You can check detailed information on our IGP design for IPRAN network. So you need to configure some IP prefixes to merge what you want to import, and also to configure route policies for us to be able to control what is being imported from one access process to another aggregation process. Remember, it's never advertised to import two access processes. So if you have access process 10 and access process 20, it's never good practice to import 10 to 20 or 20 to 10. You should have a hierarchical setup. So we have the route policies configured. These are for SP01 and SP02. We've discussed this before. I've mentioned if you want to understand it better, just check it out on our channel, on our IPRAN training series, and you will get a much clear explanation on the same. So we are configuring the prefixes to merge loopback 0 IP and also to permit the point-to-point and the system IP address configured on the UPs, and then we perform route import using the route policies. So we have route policy access to aggregation, and then import aggregation loopback. So we need to import the aggregation loopbacks to the access process. So always use route policies to control what you want to be imported. So we have this in place. The first step is to configure MPLS and MPLS LDP on UP, SPE, and NPE. Remember, we are configuring BGP MPLS VPN. So we need to do MPLS and LDP configurations. So LDP is configured as our signaling protocols, and you also need to activate it on the interfaces. First step, as usual, you always have to configure the LSR ID and enable MPLS globally, and then you can also enable MPLS LDP globally. Once you've done this step, you can now go ahead and activate MPLS and MPLS LDP on the interfaces, physical interfaces that are in our MPLS backbone network. So we do the same for NP02, LSR ID, MPLS LDP, and activate it on the interfaces. So similar configuration are done on SP01, SP02, UP01, and UP02. So we can verify the MPLS LDP status. On this router, I can display MPLS LDP session. You can see that we have 3 sessions. On SP02, we can do the same, display MPLS LDP session. We have 3 sessions. On NPE, display MPLS LDP session, we expect to have 2 sessions. NP02, we also expect to have 2 sessions. Display MPLS LDP session, we have 2 sessions. On UPEs, we also expect to have 2 sessions. Display MPLS LDP session, our 2 sessions are up. On UP02, display MPLS LDP session, you have 2 sessions that are in operational state. So this one verify that our MPLS and LDP configurations are okay. We move to the next step of our implementation, which is to configure VPN instances. So I've mentioned that we are configuring 3 VPN instances, one for 2G service, another one for 3G service, and one for 4G service. If you have other services, you like 5G or any other signaling service that you want to separate, you can always create another VRF. And you also need to pay attention to the route distinguisher and the VPN targets. So we are using the route targets to control the route export and import between different routers. The route distinguisher will always be used to make the routes unique for different VPNs. So we have this one configured as the route distinguisher. When you check on our next VRF, we have a different route distinguisher and a different route targets. So you need to do a proper planning for the route distinguisher and the route target for your network. So these are the configurations configured on the NEs. We can verify on the SPEs. If I run display IP VPN instances, we can see that we have 3 VPN instances, 2G VPN, 3G VPN, and 4G VPN. You can do verbose and it will give you the details. You can see the configured parameter, the route distinguisher, the route target, and any other detail that you have specified. All the parameters will be indicated here. So we can verify the same on SPE, display IP VPN instance, verbose. You have these parameters configured. On UPEs, the same, display IP VPN instance, verbose. You have 2G VPN, and it even indicates the interfaces that are bound on this VRF if you have any. And it will tell you even the uptime, the address family, it's IPv4, the export and the import VPN targets, and the label policy. For us, we are using label per route. You can configure it based on your network requirements. So those are on VPN or VRF configurations. The next stage is to establish MPBGP peer relationship between UPEs and SPEs. So at this stage, we are just configuring VPN before peering between different nodes. The UPEs have to establish a BGP peering session with the SPEs. The SPEs will have to establish BGP peering session with NPEs. So we have the BGP, we are using autonomous system number 500. We configure the route ID from the loopback 0 IP, and then we configure the peering sessions. So we are peering to 2 SPEs for redundancy, so that in case we lose one peering session to the SPE, we can have another one that is acting as backup. So we are configuring it this way. IPv4 family, we are enabling the peering. On NPEs, we take a different approach. We have route ID configured. We create groups, RSG to SG group, and configure common parameters on the group. Then we activate the peer. And finally, we have the VPN Vivo peerings. Then on SP01, we are doing the same. We are creating 2 groups. So remember, this is the peering between the SPEs and UPEs and SPEs to the NPE. So we have 2 peering groups. We have SG to CSG, and we also have SG to RSG for the SPE to NPE peering sessions. So these are the configurations. Remember, again, we went through these configurations in our last episode, so you can check them out. If you want to implement the same setup in your lab, you can reach out. If you have any challenges, I'm available to support you. So under the VRFs, we are importing direct routes only. Remember, in this setup, we are now not advertising the network command. So we are not advertising the default route anymore from the SPE to the UPE for the respective VPN instances. So SP02, we do the same. And then for UP01, we are configuring peering session to SP01 and SP02. And then UP02 same. We are just configuring the BGP peering session between the UPs and SPs. So on UP display BGP VPN v4 all peer, you can see that we have two peering sessions. They are all in established state. On UP02, we can also verify display BGP VPN v4 all peering sessions. We have two peering sessions, to SP01 and SP02. On SP01, display BGP VPN v4 all peer. You have 4 peering sessions, 2 to the UPEs and 2 to the NPEs. So we expect the same, display BGP VPN v4 all peer. We also have 4 peering sessions from SPE to UPE and SPE to NPE. Finally, on the NPEs, display BGP VPN v4 all peer. You have 2 sessions to the SPEs. This one display BGP VPN v4 all peer. You have your peering session. So our BGP configurations are okay. We have the peering sessions established. Now we move to the 7th step, where we now have to configure our H-VPN solution. So for the H-VPN solution, I've mentioned that we are only advertising default routes. So we advertise default route from the SP to the UP. No. I've mentioned that with the HVPN, it's kind of confusing. Sorry for that. With HVPN solution, we are not advertising the default route. We are advertising all the specific route from the SPE to the UPEs and also from the SPE to the NPEs. So you can see that the only thing that we need to do is to configure VPN v4 peering between the two routers, between the two SPEs and NP, and then we specify the SPE as the route reflector. So the SPEs and the NPs and the UPs will be the route reflector client. So these are the configuration. We configure the peering, the route reflection functionality on the groups. So these are the configuration that we need to deploy on the SPEs. So I will copy these and then paste on our two SPEs. So I log into SP01 system, then we run this, paste, and then SP2 same system, and then paste. So with this in place, we can now verify that the UP will advertise out to the SP, the SP will reflect the routes to the NPE and any other UPE also. So we'll have an end-to-end exchange of routing information from the UPE to the SPE and the NPE. So when you check on the SPE, if I display IP routing table, VPN instance to G, you can see that we are learning routes from the UPs. These routes will be reflected to the NPE. So display IP routing table, VPN instance to GVPN. We expect to learn the same routes from the SPE. So SPE will be acting as the route reflector for the UPs and NPEs. So these are the only configuration change that you need to make. And remember, with this setup, if you don't have any local services configured on these nodes, I mean on the SPEs, then you don't need to configure the VPN instances on the SPEs. But many times we have local services on the ASGs, so we still have to configure the VPN instances on the SPEs. But if you don't have any local services, then no need to configure the VPN instances on the SPEs. That is another difference between HOVPN and HVPN. With HOVPN, you need to configure the VPN instances on the UPEs, the SPEs, and the NPE. But with the HVPN, depending on your network setup, you can fail to configure VPN instances on the SPEs, and it will be okay because it will be running the VPN v4 routes, and then it will do the route reflection to the UPEs and the NPEs. So finally, we have step 8. We need to configure the services. These already configured. And step 9, we need to configure services on the BTS. So on the BTS, we are just configuring and sub interface, and then we give it a description, always a good practice. And then we need to configure the VLAN type. Remember, this is VLAN tagging, so we need the .eq VLAN ID, which is 100. Then we do the same for other services. So we need to copy this and configure it on site BBTS. Let's see, we have site BBTS here. We need system view and then paste. Wait, you can use display ARP all to see if we are able to learn any MAC addresses. Let me check on UP1 display IP interface brief to check the IP addresses. So we have 1.1.1 display ARP all. We need to do a ping VPN instances to GVPN. This is 10.160.10.2. 10.1, let me verify again, site B, display IP interface brief. 10.2, so there is a misconfiguration here. 10.2, 162.100. Or we are configuring on a wrong interface. We need to change the interface. So on this one, we need to undo interface. We don't need it here. We should be configuring on 1020, then 300. I will edit the configurations. Get the editor. You can see the interface, so just verifying the interface connecting to this is 000, so we need it to be this is .200, then this is .0. Okay, so I will copy the configuration again and apply afresh. So let me paste, quit, display ARP all. We have it, ping 10.160.10.1. We can ping display ARP all. You can see that we now have ARP for the first IP address. We can ping the second one, the third one, ping 10.161.10.1, and then 162. If I now display ARP all, you can see that we have the MAC addresses learned from the BTS and the gateway. So all the gateways are configured on the UPE. Here again, if I now try to ping this IP, it's reachable, display ARP all, we have the MAC address table populated with the necessary information that we require. So this one verify that our routes are being propagated correctly. You can check again. If I run display IP routing table VPN instance to GVPN, you can see that we are getting the routes. All the routes are learned via IBGP. You can check 3G VPN. We also have the route for GVPN. We don't have any route here configured. Display current configuration BGP. Have import. Let me check on NP1, display IP routing table, VPN instance to GVPN. We have the routes 3G. We have the route. Then for G, we don't have any route. Doubt whether it's configured here. Display current configuration BGP. So yeah, we need to edit our BGP configuration, BGP 500, IPv4 family, VPN instance for GVPN, and then import direct. So once we import the direct route, it will be advertised now to the NPEs. So when I check here, you can see that we are now getting the route from the UPE. So it's advertised to the SPE, and then SPE will send it to the NPE. So these are the configuration that we have used for our H-VPN solution. And remember, in our last episode, we covered the H-VPN, so you can do the lab simulation for the both just to make you have a clear understanding of how to implement H-VPN and H-VPN solution on Huawei routing and switching devices. I hope you've enjoyed this session. If you've enjoyed the session, kindly like the video. You can leave your comment in our comment section. If you have any question or any challenges doing the implementation, feel free to reach out. And again, just remember to hit that subscribe button and stay tuned for more upcoming videos. Thank you.